Welcome back to Algebra with Ms. Swartz. Today we're moving on to our new chapter. We're going to be working with polynomials, which we'll talk a lot about. Today specifically we're going to be working with adding and subtracting polynomials, but just kind of an overview of our unit here. Polynomial equations and factoring is kind of our biggest pieces. So we start by adding and subtracting. It's pretty simple. We work on multiplying, and then we pretty much work on undoing that multiplication. So a lot of different pieces, but today it's important to understand kind of these basic concepts, but we will talk eventually about adding and subtracting. So to start, we want to talk about the difference between something that's mono and something that's poly. Okay, those are base words. And then we'll talk about the difference between a monomial and a polynomial. So when you're thinking about mono and poly, you might think back to even when you were in world civilizations. Talked about this with religion, and mono meant one. Okay, and so if you think about it in terms of religion, that was like one God. That's what they believed in. Poly meant many. Okay, so when we're talking about monomial versus polynomial, comes into place. We're talking about monomials. Okay, this is going to be a number, variable, okay, or product of a number and one or more variables with whole number exponents. Okay, so there's one of them, there's just one piece there. Okay, and in a second we're going to talk about the degree of monomials, but then we're going to just talk about polynomial for a second. Okay, a polynomial is the sum of monomials, okay, essentially, which will make more sense in a second. Okay, each monomial is called a term of the polynomial. So polynomials can actually have one term, which would be considered a monomial as well, but it could also have more than that, so that's why it's called poly or many. Okay, so a monomial, the thing about a monomial is we can have degrees of monomials. Okay, so let's talk about that really quickly. That's a good definition to write down as well. Okay, degrees of monomials. It's the sum of the exponents of the variables in the monomial. The sum of the exponents of the variables in the monomial. Okay, so the degree of a non-zero constant term, so like for example 1, this is a monomial, 1 is a monomial, but that degree is 0. Okay, so that's a little different. The constant 0 does not have a degree, so those are a little unique. But if I gave you an example here up above, okay, a degree of monomial, if we had 5x, okay, so it says the degree of a constant that's not a number, or that's not 0, is just 0. Okay, so there's like a pretend 0 up there. Okay, and then here we would have 1, so our degree would be 1. That would be our degree. Okay, so this is just a little important to understand the degrees. We won't work with it a ton, but we will see it a little bit. So let's do a few more examples here. Hopefully it'll make sense as we continue on. So again, your constant doesn't have a degree, but your x value here has a degree, and it's the sum of your exponents, right? So how many exponents do you have? You have 2, so that would be your degree. Okay, in this case we have an x and a y. Okay? The x has an exponent of 1. The y has an exponent of 3. So you'd have to say 1 plus 3. So your degree would be 4. Okay? Constant doesn't have a degree, but your x does, and your y does. So that would be a degree of 6. And then a negative 3. Well, a constant, again, doesn't have a degree, so this would just be 0. It's just the sum of your exponents. Okay? So for number 1, okay, constant doesn't have a degree, but your x of 4, so 4 would be your degree. Constant doesn't have a degree, your c and your d do. You're going to add them together, you get 5. So try 3 and 4 on your own. Hopefully those will be pretty easy. Okay, so now we've talked about degrees, we can talk about polynomials a little bit more. Okay, so I have a whole slide here. This is actually in your journal on page 205, I believe. Maybe not. Sorry, 207. Okay, all this information is, so if you just want to highlight some of it. But we already talked about it. A polynomial is a monomial or a sum of monomials. Okay, each monomial is called a term in the polynomial. Okay, so monomial, we've kind of talked about it, but that could be any of those things that we just looked at. These are all monomials. They only have one term. Okay, they're singular. They're all represented as one term. You're not adding or subtracting. Okay, so when we're talking about polynomials, those are all considered polynomials. They're just specifically a monomial. Okay, we can have more than one monomial, and then, you know, we go up from there. So a polynomial with 2 terms is called a binomial. Polynomial with 3 terms is called a trinomial. Okay, we could have a specific name for all, but we just encompass them all in polynomial. So here's an example of a binomial, 5x plus 2. Here's an example of a trinomial, x to the second plus 5x plus 2. Okay, we will work a lot with trinomials moving forward. Okay, now we talked about the degrees of monomials a second ago, where we added all of our exponents together, but the degree of polynomials are a little different. The degree of a polynomial is the greatest degree in its terms. Okay, so you're not adding each one, you're just taking the greatest degree. That's your degree of your polynomial. A polynomial in one variable is in standard form. Okay, so meaning it has the same variable throughout. And when the exponents of the terms decrease from left to right. Okay, so what it's saying is, if you notice here, we start with x to the third, and then my terms decrease from there, x to the second, x to the first, and then a constant. Okay, when you write a polynomial in standard form, the coefficient of the first term is the leading coefficient. So this gives you an example. This is in standard form. We have a leading coefficient here. Our degree would be our highest or greatest degree of its terms. And then we would work down from there. We have a constant term at the end. Doesn't always happen that way. In this case, we have 4 terms. Okay, so what we're going to do is talk about the degrees of the polynomials, and we're going to talk about writing them in standard form. So we're just going to do a few examples of this. So it says, write 15x minus x to the third plus 3 in standard form. Identify the degree and the leading coefficient of the polynomial. So this is a lot of vocab here. Okay, but if I want to write it in standard form, I want my greatest exponent first. So in that case, that would be here. But remember, everything in front of it, or the sign in front of it, is what goes with it. So we'd have negative x to the third. Okay, then the next one would be plus 15x plus 3. This is in standard form. It's working in descending order. Okay, now my degree is my greatest degree, so my degree would be 3. And the leading coefficient, I'm looking right here, number out in front. Well, my leading coefficient then would be -1 because I have that negative out in front. We don't see the 1. Okay, let's keep moving here because we still have a little bit to go. So it says write each polynomial in standard form, identify the degree, and classify each polynomial by the number of terms. Okay, so in this case, there's really not a lot we can do. It's a monomial, so it stays the same to stay in standard. Our degree is 4, and our leading coefficient, I guess it didn't ask for that. It just asked for to classify it by its number of terms. In this case, we only have one term, so this would be a monomial. Okay, standard form, I'm going to write the biggest exponent first, then the next biggest exponent, and then my constant always goes at the end. Okay, my degree would be 2, and this is going to be 3 terms, so this is a trinomial. Okay. And then we'd have q to the 5th plus q, 8q. 5th is the biggest, so that would be the degree of 5. And this is a binomial with 2 terms. Okay, now we're on to probably the most important part of today. And we're running out of time, so I don't want to go through this too fast, but we're going to be adding and subtracting monomials. Okay, the best thing about this is it's pretty simple. Okay, there's a couple ways you can do it. You can work horizontally or you can work vertically. Okay, I'll try to show you a little bit of both. I don't know why I moved that over here. But if we look at these, all we're doing to add or subtract polynomials is adding or subtracting like terms. Okay, so sometimes it's really easy to match up your like terms when you're working horizontally. So I'm going to start, sorry, vertically is what I meant to say there. I'm going to start that way. So I have my first polynomial there, and then I'm going to look, I want to look here, and I want to make sure that I match up the correct terms. So I want both to be in standard form. Well, this is already in standard form. This one is not. So I'm going to move my x to the 3rd here, and then 2x to the 2nd here. I don't have an x term, so I'm going to kind of leave that blank. And then I have a -1. Now, what I can do is I can say +0, because that doesn't change anything. But I only want to add like terms, okay? So if I'm adding these, I only want to combine ones that are like terms. So these are like terms because they have the same exponent. That's how we know if they're like terms, if they have the same exponent. So I can combine those, and I can say that's, get my pen back. (3x to the 3rd). All I did was add the coefficients. Now I have a -5x to the 2nd plus 2x. Still just looking at those coefficients, nothing changes with my x's. So I'm going to have a -3x to the 2nd. Okay, well I have x plus 0, so plus x, and then 0 plus -1, which would be -1. And that's as simple as it is. Okay, that would be your answer. This is as simple as it gets. You can't combine anything else because they're not like terms. So if we look at B, okay, I don't have to line them up vertically. I could just do them horizontally. I could find the terms that match, 3x squared plus x squared. Okay, those match. So that would be 4x squared. And I'm going to use a different color. My x's match up. So plus x plus 4x, that would be plus 5x. And then I have two constants. -6 plus 10 would be 4. So that works the same way. Okay. If you want to do it horizontally or vertically, it doesn't really matter as long as you're consistent in making sure that you're combining your like terms. Now, subtraction I think is a little bit different because you have to make sure that you're doing it in the right order. So I like to do subtraction vertically. Okay, so in this case I have 4n squared plus 5, and I'm going to subtract -2n squared, and I want to match up what I have here. Okay, we don't have a 2n, but we do have a -4. Okay, so I know that I'm going to be working with these two and these two. Nothing's really going to be affected here, but now I'm subtracting, so I have two options. I can really think through the subtraction, or I could say plus, and I could change every sign inside here. Okay, up to you how you want to do that. We got to make sure you follow your integer rules. So 4n squared plus 2n squared would give me 6n squared, plus negative 2n, or minus 2n, because we don't have another one of those, and then plus 9. So be really careful with your subtraction. I would suggest changing it to addition. So I guess I could work horizontally here. I could say plus, negative, plus, plus, because I did keep, change, everything inside. Okay, now match up my pieces. 4x squared plus negative 3x squared would just be x squared. Negative 3x plus x would be negative 2x. And 5 plus 8 would be 13. So you could make that happen, but you have to follow your integer rules by keep, change, change. Okay, if you want some more practice, you can work on these, okay? And I can check them if you'd like. I know this video got long, but I can check it. But your homework is in page 207, 208 in your journal. Have a great day. See you soon.